Hello everyone. In this video we're going to be solving a system of equations with logarithms, or a logarithmic system of equations. So we have log y minus log x is equal to 2 and log y minus x is equal to 3. And we're going to be solving for x and y values. Now let's make sure that we understand this correctly. Log here means base 10. Sometimes it's used instead of the natural log, unfortunately, but in this case it is used for base 10. So log of any number a is meant to be log a with base 10. Okay, so we don't write base 10. So how do you solve such a system? Obviously we're going to be using some identities to solve the system, and that identity is, first of all, wait a minute, isn't log y minus x the same as log y minus log x? So what's going on here? Log y minus x, doesn't that equal log y minus log x? In which case we would have 3 equals 2. But that's impossible, right? Well, this is not the case. Obviously, this is not an identity. So log of a difference is not necessarily the difference of two logs. I mean, it can be in certain situations for specific values, but not in general. So what is going on here then? Well, the second expression actually cannot be expanded or condensed because it's just what it is. But we can do something with the first equation, which is the difference of two logs. So when you see a difference of two logs, you can use the quotient property. This is called condensing it because we have an expression that's been expanded as a difference and we're going to write it as with a single log. Make sense? And here's what the rules are. For this, we have the product rule, which is log of AB equals log of A plus log of B. Again, this is base 10, but it doesn't matter. This is true for any base. And with the quotient rule, it's just a difference. And of course, we also have a power rule, which says if you have log A to the power n, then you can basically write it as n times log of A. And obviously, for specific situations, you can say if n is equal to -1, for example, log a to the power -1, which can also be written as log of 1 over a, is negative log of a. So log of a number and the log of the reciprocal of that same number, they're basically opposites. When you add them, you get 0. Make sense? Okay, so these are some of the interesting and very helpful properties of logs. So we're going to use the second property here, number 2, for our purposes. So we have the difference, and of course these properties work both ways. So we can write log y minus log x as log of y over x. And then of course we're given that log y minus log x is equal to 3, right? Great. And from the first equation we have, the second equation, well, actually that's not true. It's supposed to equal 2. So log y over x is equal to 2. And now we also know that log y minus x is equal to 3. So now this is our new system. And let's go ahead and clear this area. Let's get rid of all the properties. Hopefully you've taken note or took a screenshot, whatever. And you can pretty much find these properties anywhere. But they should be well known. Now we're going to go ahead and use these two properties with our system. So now how do we use it? At this point, obviously there's nothing that will simplify this further. But one thing you can do is use the definition of logarithm. So that's another property that's actually the most important one, because by using that, you can pretty much come up with any property. And this is how it goes. If you have log a with base b equals x, then this implies both ways, obviously, if and only if b to the power x is equal to a. Of course, we have some requirements. B needs to be greater than 0, different from 1. A needs to be positive, so on and so forth. But under those conditions, this statement is true. Make sense? Now, for example, if I said what is log 8 with base 2, then you can set it equal to x. And think about it this way, like 2 to the power what number equals 8? So that's the type of question you need to ask. And of course, the answer would be 3 in this case. Simple, right? Great. And of course, we can log negative numbers too, but that's going to be a complex world. That's saved for another channel, which is called aplusbi. Anyway, so from here, what do? Let's rewrite our system. Log y over x is equal to 2, and log y minus x is equal to 3. Remember, the bases are 10 here, so let's go ahead and write little 10s there. And now we're going to use the definition of logarithms, which says from here, y over x equals 10 to the power 2, which is 100. And from here, using the same definition, y minus x equals 10 to the power 3, which is 1,000. Make sense? Now our system is much simpler to solve because we're done with the log world. Now we're in the kind of not necessarily polynomial world, but I would say probably just algebra world. Okay. Anyways, whatever. So from here we can do the following. We can definitely replace y with x plus 1,000 from the second equation and plug it into the first, but I'd like to use cross multiplication. Let's go ahead and cross multiply here. Y equals 100x, and if you plug it into the second equation, you're going to get 100x minus x equals 1,000. Great. What do we do from here? Subtract, like combine like terms. 99x equals 1,000. And then if you divide both sides by 99, you're going to get x equals 1,000 divided by 99. But unfortunately, they don't have any common factors. That's why this is not going to simplify, right? 99 is made up of 3's and 11's. 1,000 is 2's and 5's. And then y value is just going to be 100 times this. So y is going to be, if you multiply 1,000 by 100, you're basically going to be adding 2 zeros, which is going to give you 100,000. If you want to use commas, that's fine. I don't like them. But this is going to be the ordered pair that solves our system. Obviously, you always need to check to make sure that your values, the values you find are valid in the original system. So you can kind of go ahead and plug them in. Either you can do a check to make sure that you got the right answer, or you can check to make sure that these values are acceptable. Because suppose you got something like, of course, it's not going to happen in this case. Everything is kind of like so linear. But if you had some quadratics or some radicals, of course, you would have to check the domains. But we got to make sure that x and y are both positive, which is they are, and y minus x is also positive. And of course, that's the case. Y is greater than x. But if you want to plug it in, you're going to notice that, yes, they will satisfy the equation. But one thing that's kind of interesting is that, do you think, I mean, the first equation is kind of, if you divide them, 99 is going to cancel out. Remember, this was the same as log y over x, right? But let's take a look at the second equation. The second one is kind of interesting because if we subtracted this number minus the other number and then log the difference, I know those are 99s, would it actually equal 3 from here, right? Okay, if you subtract 1,000 from this number, what is 100,000 from 1,000? Let's go ahead and subtract those. And you're going to get actually 99 with 3 zeros. And when you log it, it's going to be log of 99,000 divided by 99, which is going to give you 1,000. And of course, log of 1,000 is log 10 to the third, and that's equal to 3. So yes, that's going to work. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.